You know that furniture you've got at home? Your bookshelves, your cabinets? Well, today we're going to dive into the secret sauce that holds it all together. It's a chemical recipe, and it turns out that a tiny little tweak to that recipe can make a huge, huge difference.
Okay, picture this. You just finished building that new flat-pack bookshelf. You're feeling pretty proud. And then you spill your drink on it. That little moment of pure panic, it all comes down to a tiny flaw in the chemistry of the wood. And today, we're going to see how some smart engineers totally fixed it. So, the stuff holding most particle board together is a glue called Urea-Formaldehyde Resin. Let's just call it UF resin for short. It's everywhere because, well, it's cheap. But it's got one major weakness. It absolutely hates water. The second it gets wet, the resin starts to fall apart, and your furniture swells up and basically turns to mush. That's the core problem we need to solve. All right, so to fight this water problem, manufacturers have a kind of secret weapon, a chemical called melamine. You've probably heard of it. It's like adding a superhero to the mix. It makes the glue way stronger and much more resistant to water. Sounds perfect, right? A simple fix. But there's a catch, a big one. So here's the catch. Melamine on its own just doesn't dissolve well. Seriously, think about trying to stir sand into a glass of water. It just sinks to the bottom, right? It's the same idea here. You can't get the melamine to properly mix into the resin, and if it doesn't mix, you don't get any of those awesome strengthening powers.
So what do? Well, the chemists got clever. They came up with a workaround. They take that melamine and they turn it into something else, a salt called melamine acetate. And this stuff, it dissolves perfectly. Problem solved. All the water resistance we need is now in the mix. But in fixing one problem, they created a whole new one, a huge one. The original recipe for making this new ingredient was just unbelievably wasteful.
And that's really the heart of this story. The original process was so bad, so inefficient, it was almost not worth doing in the first place. Okay, take a look at this. This is that original, wasteful recipe. On the left, you see what goes in. A whole lot of water, 1,000 grams of it, plus some melamine and acetic acid. Now follow the arrows through the whole process, and look what comes out the other end. Just 25 grams. That's it. 25 grams of the good stuff. Let's put a number on that. The productivity of this whole process was just 2.3%. 2.3. That is just insane. Almost everything you put in is getting wasted. Just think about that. For every 1,000 grams of stuff you feed into this thing, you're only getting 25 grams of actual product back. The rest, it's basically just expensive chemical-filled water. And you can't just dump it, because it's full of the valuable product you actually want. Getting it back would mean boiling off all that water, which costs a ton of money and energy. There had to be a better way. Okay, so this is where the really cool chemical engineering comes in. The researchers came up with this awesome two-part solution. And the first part was so simple, it's brilliant. They basically just asked, what if we could, cram more ingredients into the same amount of water? Here's what they figured out. The moment the first ingredients react and dissolve, the water's technically empty again. It's ready for more. So they'd start the reaction, wait for it to clear up, and then, boom, they'd add another small batch of ingredients. And guess what? It dissolved. So they did it again and again. They just kept feeding the reactor, little by little, until it absolutely couldn't take another drop. And you can see exactly how they did it right here. They start with the base reaction, then they just keep adding more raw material in these successive steps. Look how the solution stays perfectly clear until the very last addition. It's amazing! With this one simple trick, they managed to pack in more than double the raw materials using the exact same amount of water. Okay, so that first idea was a total game changer for getting more product. But you still have that leftover liquid, right? The stuff that's full of valuable chemicals? Well, this is where the second big idea comes in. Close the loop. Waste absolutely nothing. It's so simple, it's just genius. Instead of treating that leftover liquid, they call it the mother liquor, as waste, they just used it to start the next batch. All that good stuff that used to be waste, now it's the starting point for the next round of production. It's a perfect self-contained recycling system. And the impact of this was just huge. I mean, you're recovering basically all of your product now. You're reusing the water, which slashes the need for fresh water by over 90%, and you can get rid of all that expensive, energy-guzzling equipment you needed to boil off the wastewater. It's a win-win-win-win. So, the new process is way, way better. It's cleaner, it's cheaper, more efficient. But here's the million-dollar question. Does the final product still work? Does it actually make the furniture better? Oh yeah, it absolutely does.
Let's just look at the numbers. The old method, on the left, had that pathetic 2.3% productivity. Now look at the new process on the right. It jumps all the way up to over 11%. That is a 5-fold increase in efficiency just from rethinking the recipe and recycling the waste.
But what does that mean for your actual furniture? This is the really cool part. Look at this table. See that thickness swelling row? That's the big water test. The standard says it has to swell less than 12%. The original stuff fails badly, but with our new additive, it passes with flying colors at 10%. And not only that, it also makes the board physically stronger, pushing it well past the minimum strength standard, so it's better all around.
So what's the big takeaway here? It's that smart design is about so much more than just making more stuff. By thinking creatively, by packing more in and then recycling everything, these researchers didn't just cut waste and costs. They ended up with a far better, stronger, and more durable product for all of us.
And that really makes you think, doesn't it? This whole idea of closing the loop, of seeing waste not as garbage but as a resource, is so powerful. It makes you wonder, where else could we apply this kind of thinking to make the things we use every single day better, smarter, and way more sustainable?